Hello viewers, welcome to K Diagnostics. Dio here. Today we have a 2013 Mercedes Sprinter with a 3.0 liter. The customer complaint on this vehicle is there is a light that remains on the dash while the engine is running, and that light shows an exhaust system with a couple drops on it, and there is a message that displays on the dashboard display, and this message says check DEF system. So when this vehicle was first brought to me, the first question I asked the customer was if he has recently added DEF fluid to this vehicle. And the customer said that he actually added DEF fluid yesterday, and the DEF system is full with the diesel exhaust fluid. So I also confirmed that. I will show you in a minute. I checked to see if there was DEF fluid in the vehicle. Yes, the system is full and there's DEF in it, but this light keeps remaining on while the engine is running. So if you have this light come on your vehicle, make sure you have enough DEF fluid in the vehicle. If the light keeps coming on, then take it to someone who can look at it for you. So I have already confirmed that the vehicle has enough DEF fluid. Now what we're going to do is we're going to go inside the vehicle and confirm the customer's complaint. After confirming the customer's complaint, we're going to connect a scan tool to the vehicle to see what kind of trouble codes we have in the engine computer. We're going to scan the engine computer and the Addblue computer, because the Addblue computer is the computer that's in charge of the DEF system. So now let's go inside the vehicle and confirm the customer's complaint. So now I'm going to start the engine so we can confirm the customer's complaint. So right there, as you can see, the engine is running. If you look over here on this display, I hope you can see it, there is a message here that says DEF check, okay, or check DEF. So diesel exhaust fluid check. So check diesel exhaust fluid system basically. And then there's this light over here that the customer is complaining about. So this light shows the exhaust system and 2 drops on top of it, okay. So there's something wrong in the Adblue system. When you have this light come on the dash, this is usually caused by a defective mirroring valve or injector, okay? Because there's an injector on the exhaust system that sprays the DEF fluid in the exhaust system, okay? So we have confirmed the customer's complaint. So now I'm gonna turn off the engine. So we're gonna turn the key on. I'm gonna get a scan tool connected to the vehicle, and then I'll bring you guys back up so we can scan the Adblue control unit to see what kind of trouble codes we have. So I will get the scan tool connected and then I'll bring you guys back up. Alright guys, so I got the scan tool connected to the vehicle. So we're gonna go straight to the Adblue control unit. So we're gonna click on this control unit over here. So let's talk to it. Let's go to codes. We have one trouble code in the Adblue control unit. Our trouble code is P2047-13. Adblue mirroring valve 1, cylinder bank 1 has an electrical fault or an open circuit. There is an open circuit. Current pending stored. So this here tells me, this trouble code here tells me that there is something wrong with the mirroring valve, okay? Some people call it an injector. There is an injector in the exhaust system that sprays the DEF fluid in the exhaust stream when the Adblue control unit wants it to. And this is why we have this light over here on the dash, this little light over here that shows the exhaust system with a couple of drops on it, because these drops here represent the DEF fluid that's sprayed inside the exhaust system. So these drops are not being sprayed in the exhaust system. That's why this light is on, okay? So now let's talk about what we're gonna do so we can fix this problem. Let me bring up my scan tool here once again. So this is pretty straightforward and pretty self-explanatory. The Adblue mirroring valve, or the injector that sprays DEF fluid in the exhaust system, has an open circuit. So which means the computer is sending power and ground. So the computer is trying to turn this valve on, but the voltage that's going to it is not being dropped to ground. So that's how the computer knows that there is an open, because this valve here has two wires, and those two wires come from the computer, the Adblue computer. So the Adblue computer sends ground and power to this valve to open it so it can spray the DEF fluid in the exhaust system. So when the computer sends power and ground to this valve, it also watches the current flow when this valve is turned on. So once it sends power and ground, if there's an open in the circuit, well, there won't be any current flow, right? Because there won't be any voltage drops if the valve doesn't get turned on. And that's how it sets this trouble code. Okay, and this system is really straightforward. The system has a reservoir, a Adblue reservoir, and a pump inside the reservoir, and a heating system, and this valve that sprays DEF fluid in the exhaust system. So the pump sends the DEF fluid to this valve, and then the valve sprays it in the exhaust system, and this is controlled by the Adblue control unit. So now what we need to do is, I want to press this diagnose button. I mean, this is pretty self-explanatory, so I hope this is going to be a quick and easy one. So we don't have a lot of info over here. There are no TSBs about this trouble code, so that's good. So I'm going to back out of here. The next thing I want to do is I want to look at the wiring diagram. I already know how this is wired, but I want to show you how this is wired. So here's the wiring diagram for our Adblue control unit. So we're gonna scroll down and find our Adblue mirroring valve on this wiring schematic. So over here is the Adblue control unit. So this blue box that you see here is the Adblue control unit, and this unit is located under the driver's seat. So if you read here, it says Adblue control unit, and right next to it is our Adblue injection valve. So there's a code about this valve. So this valve over here is the valve that sprays the DEF fluid in the exhaust system. Now this valve has two wires. If we follow these two wires, you will see that these two wires go to the Adblue control unit, which means, like I said earlier, this control unit controls the valve. Now, our trouble code said that we have an open circuit or an electrical fault in the Adblue injection valve circuit. Okay, now that can be caused by an open in one of these two wires. Okay, if we have an open in this wire, that trouble code is going to be set. Or we could also have an open in this valve. If this valve is open internally, that same trouble code will be set also, because the computer sends ground on one of these wires and it sends power on the other wire, and once there's power and ground coming to this valve, this little coil over here gets energized. It moves the little valve that's inside this injector, okay, and DEF fluid gets sprayed inside the exhaust system. So we could have an open in one of these wires, or we could have an internal open in the valve itself. So now what we're gonna do is we're gonna go under the vehicle, because this valve is in the exhaust system. We're gonna go under the vehicle and locate this valve. We're gonna disconnect the electrical connector at the valve. We will bypass this valve with the test light. When we connect our test light in series with this circuit, we're gonna actuate this valve. We're gonna turn on this valve with a scan tool. If our test light lights, that will tell me that the wiring is good. So basically from the computer all the way to the valve is good. If our test light lights after connecting it between these two wires, well, the problem at that point will be the valve itself, and then we can just go ahead and replace the valve. We're gonna clear the fault code and this will be fixed. Okay, I'm gonna show you the trouble code once again. As you can see over here, it says Adblue mirroring valve has an electrical fault or an open circuit. Okay, and if we go back to our wiring diagram with the code we just saw, the open circuit is going to be either in this wire or this wire over here. So we're going to bypass this valve with the test light. We're going to use our bidirectional controls on the scan tool to turn this valve on. If our test light lights, then our open is inside the valve itself, inside the injector, and then we will just replace the injector. This will be fixed. So now let's go under the vehicle, do the test at the injector electrical connector. Alright guys, so we are here under the vehicle. Here is our Adblue injection valve. So this is the injector that sprays the DEF fluid in the exhaust stream. So I'm going to disconnect this electrical connector up here. Alright guys, so I got the electrical connector of this Adblue injection valve disconnected. So now I'm going to get some test leads so I can connect my test light in series with this circuit. So I'm going to use a test light to bypass this injection valve. Okay, so once I get my test light connected, and then I'll bring you guys back up. Alright guys, so I got my test light connected in series with the Adblue injection valve circuit. So right now the test light is bypassing the Adblue injection valve. So one side of the test light is connected to one wire on this electrical connector, and then the other side of the test light is connected to the other wire on this electrical connector. So I'm using these test leads and then these jumper wires to connect to the test light. Okay, so right now we're gonna test the circuit between this connector and the Adblue control unit. If the wiring is good from this side all the way to the Adblue control unit, once I command this valve on, my test light should light or it should flicker. Okay, so now we're gonna go to our scan tool. So my scan tool is over here. So we're gonna go to functional test. Let's go to actuator test. Alright, so right there we are given a couple of tests we can do. So we're gonna go to set Adblue mirroring valve to 50%. So we're gonna click on that. So right now we're gonna turn on our mirroring valve. So let's click continue. So we're gonna start the test. If the wiring is good, our test light should light or maybe flicker. So right there guys, as you can see, our test light is flickering as our test is going on over here on the scan tool. So right there, so this tells us that the wiring is good, and once this gets to 0, the test light is gonna stop blinking. So right there, we can do it once again. So let's, as you can see right now, the test light is off. Okay, so I'm gonna turn it on once again with the scan tool. So let's click on. So right there, let's look at the test light. So the test light is blinking. So this tells me that the wiring is good from the Adblue control unit down to this valve. Okay, so that's good. We have confirmed that. So I'm going to turn this off. So let's exit out. Let's look at the wiring diagram once again. So here's the wiring diagram. We basically bypassed this valve with the test light, and when we command this valve on with the scan tool, our test light flickers. So that tells me that this wire from this connector all the way to the control unit is good, and this wire also is good. So our open is most likely here on the Adblue injection valve. So this valve over here is open, because if our open was in the wire, our test light wasn't gonna flicker. Okay, so the test light flickering confirmed the circuit integrity of this Adblue injection valve. So the circuit is good, the problem is the valve itself, and I'm sure the valve is open internally. So now I'm gonna remove that valve. Let's see how the valve looks. Then I will order another valve. Once we replace this valve, this problem will be fixed. So let's get this valve removed. Alright, so let me remove these test leads. So we are done using the test light. Alright, so now I'm going to remove this valve. So this valve has a little clamp over here that holds it on the exhaust stream. So I'm gonna undo this little bolt over here. Alright, so we're gonna move this clamp so we can get the injector removed. So here comes the injector. Whoa, look at that. You see how clogged this injector is? You see this like crispy stuff? Yeah, I mean, this injector was not working. You see this? Yeah, I mean, we're gonna have to replace this Adblue injection valve. You see this stuff over here? Yeah. And these Adblue injection valves are known to get clogged up because over time, this DEF fluid, okay, this little white crusty stuff that you see over here, clog up the orifices of the Adblue injection valve, and eventually it overheats and it just get burnt. So yeah, so this is a problem, guys. I don't even have to do a flow test on this one because this is completely clogged. There's no need to do a flow test on this. So the circuit is good. The wiring from the electrical connector here to the Addblue control unit is good. So the problem is this valve. I'm gonna get this valve ordered. Once I get the new valve, I'll bring you guys back up so we can install it. And once we install the new valve, this will be fixed. Okay, so I mean, there's a line over here we have to disconnect. Once we disconnect this line, the valve will be out. So I'm gonna get the new valve first and then I'll bring you guys back up. Alright guys, so now I'm gonna disconnect this DEF fluid nozzle from the line that comes from the DEF fluid pump. So I'm going to remove this. So I already got it disconnected off camera. So I already got this out. So you just push this clip out. So we're gonna get this out of the way. And then disconnect this from the line. So right there. Here comes our old injector, okay, or Adblue injection valve or injection nozzle. So this one component has a couple names. So we got it out. So now let's take this to the bench. I already received the new one. Remember our trouble code said that there was an open in the circuit, but we tested the wire. We bypassed this nozzle with a test light. When we bypassed this nozzle with a test light, we were able to turn on the test light on and off with the scan tool, so which told us that the circuit is good. So we're gonna ohm this nozzle. We're gonna measure the resistance of the coil that is inside this nozzle. I didn't look at the spec, but we're gonna compare the resistance on this nozzle with the resistance on the new nozzle. Okay, so I'm pretty sure this one here is open, and I'm sure once we connect our multimeter to these two pins, we will have an OL reading on the multimeter. So let's take this to the bench. We're gonna compare it with the new one. We're gonna do a ohm measurement of the coil inside this nozzle just to double check, and then we will install the new nozzle. So let's go to the bench. Alright guys, so we are here at the bench. Here is our old nozzle that came out of the vehicle. This is the new nozzle that I just got from Mercedes, and here is the part number. So I'm gonna get it out of the box. So right there, as you can see, it looks like the old one, so they both look identical. So at this point we can go ahead and install this one in the vehicle. But there's one test I want to do before we install the new one in the vehicle. Remember, we had a trouble code that said that there was an open circuit in the mirroring valve circuit, okay? And we checked the circuit with a test light. We bypassed this mirroring valve with a test light, and we turned this valve on with a scan tool, and our test light was flickering, so which told me that the wiring from the computer to the valve was good. But why did we have a trouble code that said that there was an open in the circuit? Since our wiring is good, then where will our open be? Well, our open is inside the nozzle. I'm sure the coil inside this nozzle is open because there's a coil here that gets energized to open the plunger inside this nozzle to allow DEF fluid to be sprayed inside the exhaust system to break out all the NOx that's in the exhaust system. So we're gonna use a multimeter to measure the resistance of the coil inside these nozzles. So we're gonna measure the resistance of the coil in this nozzle, and then we will compare it to the resistance of the coil in the new nozzle. So I'm gonna bring my multimeter here. So we're gonna turn that on. Let's make sure that the multimeter is in the ohm scale. So we're gonna connect our test leads to the multimeter. So the black lead is gonna go over here. So the first thing we're gonna do with my test leads not being connected together, as you can see, we have one on the screen, on the multimeter screen, which means this is an open reading. But when I connect these together, we will have a reading on the screen. Hold on. You saw that? So we have a reading because I'm connecting these two test leads together. And that means we have continuity between the test leads. Okay? So that's good. Our multimeter is working. So now we're going to use these test leads to connect to these pins over here on the nozzle. So this is going to go to the first pin, and then this one is going to go to the second pin. Alright, so we're connected to the coil inside the nozzle. So one of these test leads is going to go to our red lead, and then the other one is going to go to the black lead. Okay, and right now we're connected to the coil inside this nozzle, and as you can see, we don't have any reading on the multimeter screen, so which means that the coil inside this nozzle is open. So this is why we had an open trouble code, because the coil in this nozzle is open. Okay, so the computer could not control this nozzle because the coil inside this nozzle is open. Okay, so this over here is what was causing the problem. So it is open electrically, so the coil inside here is open, and the orifices, the holes over here, are also clogged up. So this is
completely defective. So we're gonna disconnect this one. Now we're gonna measure the resistance of the coil on the new nozzle. So one of these is gonna go over here, and then once I connect the other one, since this is new, I'm pretty sure we're gonna have a resistance reading on the multimeter. So right there, with this being connected, we are reading, hold on, yeah, so right there, we are reading 13 ohms. Okay, so 13 ohms is the resistance of the coil inside this nozzle. Okay, so this is the good one. And if we remove this cap, look at this one. You see the difference between this and this one? You see these tiny little orifices in there? But this one over here is completely clogged. Alright, so we are definitely on the right path. We made the right call. This over here is definitely the problem, because when I reconnect it, we do not have any reading on the multimeter. So right there, the coil in this nozzle is open. Okay, but if we connect this guy, we have 13 ohms on the multimeter. So right there. Okay, so this nozzle here is defective. Let's take this nozzle to the vehicle and install it. Once we install this nozzle, we're gonna clear the trouble code, we will test drive it, and I'm sure that light on the dash will go off and this vehicle will be fixed. So now let's take this nozzle to the vehicle and install it. Alright guys, so we're back here under the vehicle. So now I'm going to install this nozzle over here. Okay, so this is, we're gonna push this in place. So right there. So the line is connected, and this is gonna go over here. Actually, we're gonna put our clamp on first. Alright, so now I'm gonna start tightening this little screw over here. Alright, so that's tightened. So now I'm going to reconnect the electrical connector of this nozzle. So let me bring the light over here. So we're gonna reconnect that. Alright, so that's good. So now let's go inside the vehicle and erase the trouble code. Then we will take this on a test drive. I told you guys that I was gonna show you the DEF fluid that they filled up. So the DEF system is filled up. So the customer already filled the system with diesel exhaust fluid. So I was just gonna show you so you can see that the system is not empty. I don't know if you can tell. It's gonna be hard for me to show you, but I don't know if you can see in there, but the system is not empty. Okay, there's definitely DEF fluid in there. Okay, so as you guys saw, our nozzle was open, so the nozzle was the problem. The fluid level is good. So now let's go inside the vehicle and erase the trouble code, then we will go on a test drive. Alright guys, we are back in the vehicle. Now we're gonna verify our repair before we wrap up this video. So I'm gonna turn the key on. I'm gonna bring up our scan tool here. The scan tool is still connected to the vehicle. So we're gonna go straight to the Addblue control unit. So after replacing that Adblue injector, now what we're gonna do is we're gonna erase the trouble codes. So let's clear that trouble code that we had. So as you can see, we erased the trouble code. So now let's read the codes again to make sure that we don't have any trouble codes in the Addblue control unit. So right there, no codes present. So let's back out. So we don't have any trouble codes in the Addblue control unit now. So let me get the scan tool out of here. So now I'm going to start the engine. With the engine running, we're gonna see if the light that was remaining on the dash will now be off. So now I'm gonna start the engine. This is good. Remember that light that was remaining on around here, the light that was showing the exhaust system with a couple of drops on it. Right now, after clearing the codes and replacing the Adblue injector, that light is no longer remaining on while the engine is running. And if we zoom into this display, you will notice that the message that was saying check def is no longer here. There was a message on this display that was saying check DEF, and that message was displayed here when that light was remaining on the dash. Okay, so this is fixed, guys. I can leave this right over here. The problem was an open Adblue injector. Since we had a code that said that there was an open in the electrical system of the Adblue mirroring valve, we checked the valve was open. We checked the wiring was good, so we replaced the valve, we cleared the codes. Now everything is good to go. At this point, what needs to be done is we have to drive the vehicle for at least 60 miles so that the after treatment system monitor can run and check the system. After checking the system, if there is still a problem in the system, that light will come back on. But knowing that the Adblue injector was open, I'm sure if we drive this vehicle for 60 miles, that light will not come back on. So I'm gonna leave this right over here. I don't have to drive it. I'm gonna have to give the vehicle to my assistant, Chris. He's gonna drive it for 60 miles and make sure that the Adblue system monitor runs and everything is good. But I'm gonna leave this video right over here. You guys saw when we measured the resistance of the coil of the Adblue injector. On the old one, we had an open reading, which told me that the coil in that injector was bad. Okay, so I'm gonna leave this right over here. This was a pretty quick and easy one. I hope you liked this video. If you do like the video, give it a thumbs up. If you don't, give it a thumb down. But if you do, you gotta tell me why so we can make better videos in the future. If this is your first time here, subscribe to the channel. Ring the bell so you can get notified every time I upload a new video. Thanks for watching, guys. See you next time.